Welcome back to another Daishinfinity video. In this video, we're going to talk about the derivative of the hyperbolic cosine of x. Now, it states that the derivative of the hyperbolic cosine of x is equal to the hyperbolic sine of x. So we are going to prove this in this video using some limit definition of the function. Now, using the limit definition of the function, it states that any function given, the derivative of any function f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, using this fact, we would normally put in the cosh of x plus h minus cosh of x over h, but it will not help us into proving this formula, which means we are going to use another demonstration for this hyperbolic function. The other demonstration for the hyperbolic function goes as follows. We are going to use the exponential function e to the x. It states that the cosh of x is equal to e to the x plus e to the negative x over 2. Now we can use this fact and put all of our e to the x functions into our limit, which would make it easier for us. So we will have the limit as h approaches 0 of the x plus h as an input. So we will have e to the x plus h plus e to the negative parentheses x plus h all over 2. And then negative e to the x plus e to the negative x over 2. And the whole thing over h. Now, since we have the same denominator, we can put it into a unified fraction, which will lead us to having the limit as h approaches 0 of e to the x plus h plus e to the negative x plus h over 2 minus e to the x minus e to the negative x, distributive rule. You see the negative sign in front of the fraction, so we would have to use the distributive rule to put it like this, and the whole thing over 2h. Now, using the exponent rule, we have that a to the n plus m is equal to a to the n times a to the m. So here we can say that we have the limit as h approaches 0 of e to the x e to the h plus e to the negative x e to the negative h minus e to the x minus e to the negative x, and the whole thing over 2h. Now we can say, okay, we have e to the x and we have some e to the negative x components, so we are just going to use it to make parentheses out of it. So we are going to group them. So we have the limit as h approaches 0 of e to the x times e to the h minus 1 plus e to the negative x times e to the negative h minus 1 over 2h. Now we have a plus in the middle, so we can split this up into two fractions and then take the limit on two of them, stating that we are going to use the limit rule, stating that the limit of a plus b, or a plus minus b, is equal to the limit of a plus minus the limit of b. The proof of this equation, I'm going to prove it in another future video, but for now, let's just write it down. So we just have the limit as h approaches 0 of e to the x times e to the h negative minus 1 over 2h plus the limit as h approaches 0 of e to the negative x times e to the negative h minus 1 over 2h. Now, e to the x and the 2 and the e to the negative x and the 2 are both independent of h, so we can put it outside the limit. So we will have e to the x over 2 times the limit as h approaches 0 of e to the h minus 1 over h plus e to the negative x over 2 times the limit as h approaches 0 of e to the negative h minus 1 over h. Now we know from the past videos that I've proven the derivative of e to the x. And when we try to prove it with using the limit definition, we come across this form of the limit. And we have stated that this limit goes to 1 or approaches 1, which means we are just left with e to the x over 2. But for the other limit, we have to do something. And what I want to do is I want to get to this form e to the h minus 1 over h. So let's just multiply both sides by e to the h. So the denominator and the numerator. Then we'll get e to the x over 2 plus e to the negative x over 2 times the limit as h approaches 0 of 1 minus e to the h over e to the h times h. Now let's use the property of swapping the components using the negative. So we can use one negative sign here and another negative sign here so that we can get a positive together. It will not change anything. So here we would get e to the x over 2 minus e to the negative x over 2 times the limit as h approaches 0. Using the distributive rule, we'll get e to the h minus 1 over e to the h times h. And we know this limit. So we just want to split it up into 2, and we can do it because we have a limit rule stating that limit as a times b is equal to the limit of a times the limit of b. Which means that we have the e to the x over 2 minus e to the negative x over 2 times the limit as h approaches 0 of e to the h minus 1 over h times the limit as h approaches 0 of 1 over e to the h. And the limit of 1 over e to the h is equal to 1. And this is also equal to 1. So we're just left with e to the x over 2 minus e to the negative x over 2. Putting those two fractions into one unified fraction, we'll get e to the x minus e to the negative x over 2. Also the definition of the sinh function. So I hope you really like this video, and we'll definitely see us in the next Daishinfinity video. See ya.